Good evening, students. Today we are discussing about from the solution topic. We are discussing subtopic colligative properties. And to the question, the bond half factor for 0.5 molar aqueous CH2FCOOH solution is 1.075. And what is the experimentally observed delta TF in Kelvin for this solution? So Kf value also the given. So now coming to the given information, the want half factor for 0.5 molality. So the given small m 0.5 molar cap small m the given. So cap small m means what is that? That is the molality. So molality value how much the given? 0.5 the given. And which solution that is? CH2FCOOH. This is the solution. And want half factor we are denoted by I value how much they given? 1.075. Want half factor is 1.075. And what is the experimentally observed delta TF? So delta TF, how much they are asking in Kelvin, units are Kelvin they are asking. And next one, the given Kf value also the given, that is the 1.86 Kelvin kg per mole. Kelvin kg per mole they are asking. So this is the given information. They given the molality 0.5 and solution is the CH2FCOOH and want half factor I they given. So now they are asking delta TF, Kf value also they given. So this is depression in freezing point. This is the colligative property, one of the colligative property, that is the depression in freezing point. So delta TF equal to formula I into Kf into M. I into Kf into M. I means what is this? This is the want half factor and Kf is the, this is the depression in freezing point constant and this is the M means that is the molality. So I value how much they given? 1.075 and Kf value also the given 1.86 and molality also the given 0.5. So total value if you are calculated, so this is 0.5 into this is 1.86 means this in this half only, that is the 0.93 will come. So 0.93 into 1.075 if you done, nearly you will get the 1. So delta TF equal to how much? That is the 1 Kelvin. So this is the answer for this question. The given I value the given, Kf also the given, molality also the given. So total delta TF formula I into Kf into M. So this total values if you substituted, you will get the 1 Kelvin. This is nearly 0.5 means half into 1.86. Now you will get the 0.93. So 0.93 into 1.1 nearly 1. Then you will get the nearly 1 value. If you are calculated exactly, you will get the 1 only. So delta TF depression in freezing point equal to 1 Kelvin. So this is the answer for this. Thank you. Next question. This is from May 23rd. This is May 23rd and 2025 question. So what is the question mean? A solution of urea in water. So what they given? Urea solution the given. Boiling, what they given? Boiling point they given. So boiling point is represented by TB. Of solution, how much they given? Boiling point of solution, that is 100.18 degrees Celsius they given. So boiling point of solution they given. What is the freezing point of the same solution? Means they are asking TF for solution. What is the freezing point of the solution they are asking? So question mark, keep the question mark. And after that what they given? If Kf and Kb of water. So Kf of water they given, that is 1.86 Kelvin kg per mole. Kf is the 1.86 Kelvin kg mole inverse. Next Kb how much they given? That is the 0.52 Kelvin kg mole inverse they given. Next boiling point of water also. Boiling point of water means this is water is act as a solvent. So pure solvent boiling point, how much they given? 100 degrees also they given. So this is the question information, given information. So what is the solution? That is the urea solution. Urea solution is nothing but what is that? Urea is dissolved in the water. So here water is act as a solvent. Here water is act as a solvent. So solvent is it is a pure state. So then boiling point how much? 100 degrees. If added urea into the water, then its boiling point is increased to 100.18. Initially pure solvent water, if you are taken, boiling point how much? 100 degrees. If adding after that urea adding, then what is the boiling point? Then 100.118 degrees Celsius. Means what happened? Boiling point is increased. How much is increased? Means this is initially 100 degrees is there. After adding the urea, how much is there? 100.18. So that is the increased temperature, increased in the boiling point, that is also called elevation in boiling point, that is the 0.18. So now what they are asking? TF for the solution, means freezing point of the solution they are asking. So now we know the formulas. Delta TB equal to KB into M. Next, delta TF equal to KF into M. So what you can write? M equal for both same solution only. So molality is the same for that. So from this what we can write? Molality equal to KB, turn that side, delta TB by KB. So this molality substitute in this. So delta TF equal to KF into molality, how much this is? Delta TB by KB. So we know KF value and KB value. Delta TB calculate. Delta TB how to calculate? Delta TB means that is the elevation in boiling point. So elevation in boiling point, how to calculate? Boiling point of solution minus boiling point of pure solvent. So boiling point of the solution, how much they given? 100.18 minus boiling point of the pure solvent. Pure solvent means water. How much they given? How much that is? 100 degrees. So delta TB equal to how much? That is the 0.18. Means this is the elevation in boiling point. Initially pure solvent is there. After adding the urea, its boiling point is increased to 0.18. So this is the delta TB value. So now substitute all the values. KF value how much? That is 1.86 into delta TB. Delta TB how much we got? 0.18 by KB. KB how much this is? 0.52. So this calculation observe, this is the 0.18 means point after two places. Here also point after two places. So point will be cancelled. Then 8 in 1, so 8 in 3, nearly 8 in 3s are 54, nearly 3 value. Then how much you will get? 1.86 by 3, then that is the 0.62, nearly. That is the 0. So delta TF equal to how much we got? Delta TF equal to 0.62, nearly 0.64 will come. 0.64. Now delta TF, what is the delta TF? This is the depression in freezing point. So depression in freezing point, how to calculate? This is the TF of pure solvent minus TF of solution. Mean why? Because freezing point is decreased after adding the urea. Initially water freezing point, here pure solvent, which one? Water. After that, after adding urea, its boiling point is decreased. So that's why we are calling this is the depression in freezing point. Boiling point is elevated. Why? Because here initially 100 degrees is there, and final after adding the urea it is becomes like a 100.18, means boiling point is increased. Here freezing point is decreased. So this is called elevation in freezing point. This is called depression in freezing point. This is called elevation in boiling point. So elevation in boiling point 0.18. We are getting the depression in freezing point. This is the 0.64. So depression in freezing point, how to calculate? Means pure solvent freezing point minus solution freezing point. If you are calculated, then we are getting the delta TF. So delta TF how much? 0.64 we got. Now freezing point of pure solvent. What is the solvent here? Water freezing point how much? 0, 0, 0 minus TF of solution equal to 0.64. So now TF of solution equal to this one. Now if you are converted, then minus 0.64. so this is the solution freezing point. How much? Minus 0.64. Here what they given? First, urea solution. Urea solution boiling point they given 100.18. Then freezing point how much they are asking. So Kf and Kb values also they given. So how to calculate this one? And solvent boiling point also they given 100 degrees. So we know the two formulas, that is the elevation in boiling point to depression in freezing point we know. So delta Tb equal to Kb into m. Here delta Tf equal to Kf into m. So this is total one solution only. So molarity is same only. So molarity equal to what you can write? Delta Kb on that side, delta Tb by Kb. So this molarity is now substitute in this. So delta Tf equal to Kf into m molality. What is the formula? Delta Tb by Kb. So now Kf value they given and Kb value also they given. Delta Tb. Delta Tb how to calculate? That is elevation. Elevation means initially pure solvent, after adding the urea its boiling point is increased. So increased point minus, this is solution boiling point minus solvent boiling point. If you will get the delta Tb. So delta Tb total values if you substituted, you will get the 0.64. so that is the delta Tf, means depression in freezing point. So depression in freezing, here elevation in boiling point how to calculate? Solution boiling point minus solvent boiling point. Here depression in freezing point how to calculate? Means solvent freezing point minus solution freezing point. You will get this delta Tf. Delta Tf we got 0.64, so equal to them. Then Tf of solvent, pure solvent, what is that? Solution. So solution, sorry, water solvent freezing point how much? That is the 0. So 0 minus Tf of solution equal to 0.64. Then Tf of solution equal to minus 0.64. So this is the freezing point of the solution. How much? Minus 0.64. Thank you.